breaking all the rules. From Newton to Einstein, concepts elevate. Keep the stream, it's the key to our fate. Dr. Gold dropping gems, knowledge raining down. Actual education making scholars all around. Perpendicular minds, angles sharp as ice. Maths and physics, yeah, the future's real nice. Got the Pythagorean triangles about to flex. Quantum theories on deck, breaking all the specs. Relativity theories, worlds getting small. Grasp the universal laws, standing tall. From the atom to the cosmos, we rolling deep. Grazing up the stars, no time to sleep. Black holes and supernovas, concepts we unfold. Brain power heavy, yeah, that's Dr. Gold. Dr. Gold dropping gems, knowledge raining down. Actual education making scholars all around. Perpendicular minds, angles sharp as ice. Maths and physics, yeah, the future's real nice.
All right, what's up, everybody? Let me go start this. What's up, Isaiah?
Hey, Professor, how's it going? I'm just here to see the problem that we reviewed.
For sure.
The circuits one? Sorry.
The which one?
Today in the review session, we had like the last problem. It was the circuits one.
Oh, yeah, the circuits one. Yeah, let's do that one. I'm curious about that one, actually. Yeah. Let me pull that up. Ooh, let me go. Boom, 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 boom. Where's my chat? Put my chat back. Chat. There we go. All right, let's see. Yeah, not this one. It was this one, right?
Yep, this is it.
Yeah. Okay, cool. All right. So, first step on this one, right, was to label some currents. Is that all kind of clear? It's all Gucci, like how we label currents?
Yeah, we got the loops, we got the currents. I'm a little
Perfect.
curious. So you did like minus and plus for all the voltages, and
Yes.
then that showed us like which way everything was going.
Yeah. Well, yeah, when we do the loop, if the direction of the loop we're going in matches the direction of what I think the current's going in, then that's a subtraction for going across resistors. If it's opposite, it becomes a plus. And I think I explained this yesterday. Were you here yesterday for office hours? I did it with what's his face, Jack. It's okay if you weren't.
I wasn't.
Okay, cool.
Are we gonna use like RF to solve this problem?
We are going to use RF, yeah. Reduced echelon form. So the reason why it's subtracting, okay, so let's say, for instance, this is positive, this is negative, right, for a battery. And let's say this is, for instance, 0 volts, and then this is 12 volts. So it's a 12-volt battery. I'm going to define current as being in this direction. I'm going to call this like I1, right? So this is also I1, whatever, this is also I1. Okay. What Kirchhoff's loop law says, right, is that the change in voltage from like one position, so let's say from one position to another position, is equal to the sum of whatever these like voltage drops are. Now, in the case, if I start and I like end at the same position, right, then this change in voltage should be 0, right? If we start here, go around, and we come back to the same position, these should be at the same potential, so the change in potential should be 0 for closed loops. Okay? So I'll talk about like what are these change in voltages. Okay, well, when you go across a battery, you go from low potential to high potential, right? Let's say our loop is going this way. So as I travel from low to high, right? That's going to be a positive 12 volts. Because we're going across a battery, all right? Now, as we come across the resistor, all right? Let's think about the resistor, what the positive and the negative part of the resistor is. So this is connected directly to the positive part of the battery. So this is positive. This is directly connected to the negative part of the battery, so this is negative. So this is why this is going to be a negative voltage change. Or what we say is like, in that case, I times R. Because you're going from the positive end of a resistor to the negative. Okay? That's why, if we were to do this loop, this would be like sum of voltages is equal to 12 minus I1R1, and that's equal to 0. And that's just because we defined the motion of current to be this way. Let's say we went the opposite direction. Okay? So, if we go the opposite direction, let's say we start here, and we come around this way, right? In that case, now when we come across the resistor, we're going in the opposite direction of what I defined the current as to being. That's going to be adding I times R. And also you can see that because I'm going from a minus part to the plus part of the resistor. So here we would say, oh, delta V is equal to positive I1R1. But then when coming across the battery, now I'm going from the positive terminal to the negative one. And so in that case, I'm losing voltage, and that's why this becomes minus 12 is equal to 0. You see how these two things are equivalent, right? 12 minus this is equal to 0, the same thing as this minus 12 is equal to 0.
Yep.
Yeah. So that's the reasoning behind it being positive or negative.
Could you scroll to the right for a second? I'm just curious, like, what if you get the direction of the current wrong? Like, two of them are right, and one of them's wrong, or like...
So yeah, they don't even need to be right. So watch. Let's say, for instance, that I define current going the other way. All right, let's say I just messed up. Okay. Let's say instead, I don't know, for whatever reason, I thought I1 was pointing this way. Okay. Let's do our loop again, right? So let's start our loop from here. And let's go around, okay? Again, I'm going to go across the battery. So sum of voltage is going to be a positive 12. But then when I come across here, do you see how this is going to be in the opposite direction of the current? And so when I travel the opposite direction to the current, that's going to be adding. I'm going to say plus I1 R1 is equal to 0. And that's because if I'm assuming the current is flowing this way, now I'm assuming that the negative end of the resistor is here and the positive end of the resistor is here. And that may not be true. Oh, sorry. No, I'm assuming, sorry, that the positive end is here and the negative end is here. Right? Current flows from positive to negative. Now, look what happens when I do this, when I do the math. Now I get that I1R1 is equal to negative 12. Do you see how I1 will now end up being negative 12 over R1? Whereas here, for instance, I1 was equal to positive 12 over R1. So getting a negative value for your
current tells you that the current should have gone the other direction. It's just a convention. It's like you're defining what's up and what's down, and if you get negative results, it means it goes in the opposite direction.
But like that, maybe it works for that equation, but going back to like the diagram, this one, like let's say, what if the current for R4 was like going from, I don't know,
from here to here? instead of going from here to here?
Yeah, wouldn't that kind of mess up all your junction equations?
No. So it would change R4 here, right? It would make this a negative. It would make this a positive. But then when you solve for I4, you would end up getting a negative value, which would enforce this to be positive and whatever enforce this to be negative.
Okay.
Yeah. I know it's kind of weird, right? But yes. If you change the direction on these, you'll end up just getting the negative answer for I4, which then tells you that, oh, wait a minute, I should have pointed my current in the other way. We can try it. You know what I'll do? Let's put this in the matrix, and then I'll flip them and show you.
Okay, sounds good.
All right, let's do it. Okay, let's turn this into a matrix because I haven't turned this one into a matrix yet. Okay, so this is going to become as a matrix. We're gonna do like I1, I2, I3, I4, and then the value. So I'm gonna move all this over, and so that's gonna be R1 0, R3 0, 16. This one's going to be 0, R2, 0, R4, and that's 21. This one's going to be 0, 0, minus R3, plus R4, 12.
Wait, it's the other way around, right?
What's up?
It's the other way around. Like R3 is positive.
Correct. You are right, actually. Yeah. Sorry, I got that wrong. Thank you. Good catch, Isaiah. Yes. Positive, positive, negative, positive. Great. Okay, cool. And then this will be 1, 1, minus 1, minus 1, 0. Cool? All right. Let's go throw this in the calculator. What's up, Femvox? Good to see you. Oh, wait. No, I need my calculator to load. What the hell? Okay. Calculator. Alright. I'm going to do... You know what I'm going to do here? I'm gonna do 2 matrices. Well, actually, we'll do the first one. So this is going to be a 4 by 5. No. Yes, 4 by 5. It's always rows and then columns plus 1. All right, and then what was our R1 value? 10,000. Sorry. And then 0. Oop. What's it doing? Yeah, this can be 0. That's cool. R3 is 12,000. R4 is 0. And then the next one's 16. Then we have 0. R2 is 13,000. And then 0. R4 is 18,000. And then 21. And 0. 0. And then in this case, R3 is going to be 12,000. This is going to be 18,000. But negative 18,000. And then 12. And then 1. 1. Minus 1. Minus 1. Cool. And then 0. Alright. I'm going to take this matrix A, and I'm going to store it into matrix B. So I just have a carbon copy of it. Cool. And then I'm going to go to matrix B here. And let's swap. Let's see. So what were we going to swap? We were going to say R4 points the opposite direction. So on that third one, I need to make it negative, right? Or I need to make it positive, because I just need to switch the sign of it. So I'm going to make that one 18,000. And then on the second line, sorry, the third line, that last one's going to be positive. Oh, fuck, actually, I fucked that up. Wait. Uh-oh. Sorry.
Brother, this guy stinks!
Yeah, this stinks. Wait, one sec. Okay. Sorry. For the pink one, if I do it the opposite direction, right, for the pink loop, then now that one becomes negative. Okay. Well, negative here, but then I move it over, so then it's so, okay. Ugh. All this positive, negative stuff is messing with me. But, one sec. Let me do it. Okay. Pink loop is now going to become here. This is going to become plus I4R4 because I'm saying that this direction is current. And then when I move that over, that's going to be negative. So that last one on the second row should be negative 18,000. And then on the third row, if now R4, if now I4 is pointing in this direction, when I do loop C, now I'm going in the same direction of it. So this would end up being minus, but then moving over, that would become plus. Which I think I have. Yeah, I do have that. I have the 18,000. Okay, so let's see what answer we get doing RREF on both of these. So if I do matrix, math, RREF, on matrix A, that's the original one we had, we get this. Cool. So there we go. Oh, kind of some small values here. Here, let me copy this in. Nope. Okay, so this is what we got. So this is I1, this is I2, this is I3, and this is I4. Now, let's see what happens if I do RREF. On matrix B, I predict that my I4 should get switched. My I4 should become negative. Does it? Well, it actually switches a lot of things. Oh, you know what else it switches? You know what else it switches? It switches this. This is the issue. So, it will switch the loops, but I forgot it'll also switch this. So this now would need to be +1. Alright, let's go fix that. And this is the cool thing about matrices. Like, if one thing is off, it'll make the whole result completely different. Yeah, let's make this +1. Okay. Let's do it again. There we go. Bingo. Bingo, bango. Look at that.
Oh.
Isn't that
It just
fucking
makes
cool?
it negative. Wow.
Yes.
Can't believe it.
Can't believe it.
Oh, dang it.
Believe it!
It sounds like Naruto.
Oh, that's the, you know, the let's go gambling sound? Let's go gambling! And there's...
Oh, dang it.
It does sound like a little bit like Naruto. Okay, cool. Yeah. So notice, right? I4 just switches to negative, which tells me it then goes in the opposite direction. I guess it should make sense because you're defining variables, right? And in this case, you're saying like, oh, let u equal like negative I4. So then when you solve for u, then I4 is equal to negative u. So the negative just comes out later. It's like u substitution, I guess. Right? Okay. Let's see if those answers are right, by the way. I do have the solutions manual for this book. Oh, I don't need this. Where is it? Oh, quick access. Solutions manual. Okay, cool. And then what question was this? This is question 82. Ooh, what chapter was this though? Fuck. I gotta open up another thing. This was circuits, so that's chapter 19. Okay, so chapter 19, question 82. Crazy to think that people wrote solutions manuals way back in the day without AI. Like, they checked all this shit by hand. That's crazy to me, dude.
Yeah, people are really sharp.
Yeah. I start worrying if we're going to get less sharp because of it. Like, oh no. Alright, let's see.
Yeah, I have a question about math and physics education in general after we solve this one.
Oh, for sure, yeah. We can chat about it, dude. I'm down.
Okay.
Okay. Wait, what do they want? Oh, the current through this 16-volt battery. So that was I1, right? Yeah. So they define their things differently, but they did get the same answer. They called it they did call it I1. Never mind. There we go. 7.9 times 10 to the minus 5 amps, which is what we had right here. Fuck yeah. Alright, but there's still a part B. We'll do part B. Aviv says, I had a general question about defining currents. Yeah, shoot away. What's your question about defining currents? I know a common question that has been asked before is like, how do you know how to define the currents or like how to label them? That's a common thing. If that's a question of yours, just type it in chat. I'll answer it. So this is voltage. Okay, when they split at junctions, sure. This is the voltage through the 16-volt battery. Can I speak? Yeah, you totally can speak. Here, you want the link? I'm not live on Discord, unfortunately, right now, but I'll give you the Google Hangout link. How do I share this with you? Discussion recording. No, one sec. Office hours. There you go. There you go. Yeah, if you want to join that link, you can hop in the VC and talk. What's up, Aviv? You're muted technically, but let me know. Sometimes you gotta figure out all the Google mic settings or whatever. But speak up whenever you can, whenever it shows that you're ready. All right, let me hide this. Okay.
Oh, there we go. Do you hear me?
There we go. Yeah, what's up, Aviv?
Okay, cool. Thank you, Professor.
Yeah, you're good.
So, on questions where like there's multiple junctions, and like I saw sometimes when you do them in lecture, like clicker, it's like, let's say you define like an I1, like starting from the battery, and then it reaches one junction, and then like the I1 like continue through the loop, and then I2 starts like it. Like, how do you know? I guess like how do you know when to like define like another current starting, and then like where does that one go?
Perfect.
Where does it like start and end? There was a question. I don't have like a specific one, but number
I'll find some
5 on the
screenshots.
most recent homework.
Yeah, I'll find some screenshots from homework. Yeah, let me pull it up.
Cool. Thank you.
Yeah, you're good, dude. Where is it? Questions. Oh yeah, this one. Yeah, this is a good one. This one's a mess. This one's a mess of a question. But yeah, it turns out you don't even need some of them. Okay, right. So, the rule is anytime that a current hits a juncture where it splits, you need to turn it into a new current. So, for instance, if I start here, right, all of this going across resistors is chill. I don't care about that.
Yeah.
But once I get to here, now I need to stop.
Right.
So all of this here is I1. Also, technically, this is I1, like to here, right? So
Okay.
if I wanted to put arrows on it, right, I would say arrow, arrow. And this is all like the definition I'm having for I1.
Yeah.
Okay, so once you get here, or like once you get here, right, now I got to turn it to something else.
Mm-hmm.
So this, for instance, they end up calling this like I3.
Yeah.
Okay, but then I have to stop here because I'm hitting another juncture. And then this one, for instance, would be here. To like corners don't count.
Right.
So cool, cool, and then I have to stop. And so then this is what I5. That's why you have to then define another current here, just between these two, which they're calling, I guess, IB.
Mm-hmm.
And then, let's see. This one still counts as one. So this one's good. And then you finally have this one right here. Yeah.
Mm-hmm.
And then again, it doesn't matter what direction you draw the arrow, because that can be confusing sometimes. Based on the voltages and where the batteries are, it can get hard to predict where the current's going to go. But as I showed with Isaiah previously here, even if you decide to like put the direction and you end up being wrong, what'll happen when you do the math is you'll just get a negative value for that current. And so that tells you it runs the other way.
Mm-hmm.
Yeah.
Okay. That makes sense.
Okay, good.
Thank you.
I should probably teach it like that at first, but yeah.
I appreciate it. And then like there was some, I guess this kind of like answers what I'm about to say, but like there was some where I'd see like, so I1 would split into like what we call I2 or I3, and then it would like rejoin. And I guess that's just like that little part right by the negative.
Yeah. So in the case of, let's say for instance, you have a circuit that does like something like this.
Mm-hmm.
I don't know. Let's say resistor, right?
Yep.
Technically, this is all like one current.
Yeah.
But then you have two different currents here.
Mm-hmm.
Yeah. Because again, or well, I guess I could have it like go all the way down, but whatever.
It's like every possible path, kind of.
Every possible path, but anytime a path breaks up, you technically have to turn it to a new path. Here, right, I technically need to turn this into a new path, but it just so happens that this path connects back directly to the beginning of my original path, so I can call it the same thing.
Got it.
Yeah.
Cool.
Wait, I should make a
Thank
video
you,
on this
Professor.
one. Yeah, you're welcome, dude. Yeah, feel free.
Appreciate it. Thank
All
you.
right, let's do part B here. So we got the right answer for that. The question then was find the potential difference between points A and B. Right, so I was explaining this at the end of class that Kirchhoff's law, this sum of the voltages is equal to 0. That's just like a cute coincidence because we're doing delta V when the start and the finish are the same. And so the potential difference between where you start and like where you start should be 0. If the start and finish are different, however, then you're going to get a non-zero value. And so that's what I said for here. I said, okay, the change in potential from A to B is equal to the sum of the voltages. And in this case, it's not a loop we're doing anymore, right? It's just a path. And so what I said was, if you're starting here, then as you go across this resistor, if we have defined I1 to be this way, that's going to be minus I1R1. And then as we go from here to here across I2, well, I2 is pointing this way. So I'm going the opposite direction as I2. So for resistors, that's a plus I2R2. And I think this is equal to, again, voltage B minus voltage A. I'm pretty sure. No, wait. Yes, I think it's VB minus VA. Let's see. I'm curious, actually. All right. I1 was this 7.9 times 10 to the minus 5. So I'm going to have negative 7. or whatever, 8 times 10 to the minus 5. And then times R1. R1 was 10,000. So 1 times 10 to the 4. And then we're going to say plus I2. Oh, I2 is ugly as anything. 1.37, or I'm going to just say 1.4. 1.4 times 10 to the minus 3. And then what was the resistance on that? That was 13,000. That was 13. Or 1.3 times 10 to the 4. Okay. Let's plug this in our calculator. Hopefully we get like a voltage that makes sense. Alright, so I'm going to do negative 7.8 e to the negative 5 times 1 e to the 4 negative 0.78. Okay, that's cool. I'm chill with that. And then we're going to do plus 1.4 e to the minus 3 times 1.3 or times 13,000. Oh, I get 18.2. All right, let's see if that makes sense. So that's kind of a big voltage, honestly. Oh, sorry. I'm going to put minus. Not, it doesn't like negative. 17.42 volts. Wow. Is there anything that's even that high? Oh, I guess there is. This is 21 volts. This is 12 volts. This is 16. It is possible. Let's see what the solutions say. Oh, yeah. Solution says 17 volts. Okay, but it said it was negative 17. Huh. Why negative? Wait, what were they saying? Wait. Voltage A. Oh, okay, yeah. Voltage A is at 16. Voltage B is at 33. So they did voltage of A minus voltage of B. Oh, I guess it's like, which one are you referencing? Sorry. Yeah, when they say the did they say which one they wanted? Okay. Oh, they wanted VA minus VB. Okay. Ah, okay. So I wrote VB minus VA because that's what delta. So delta VA is the change in voltage from going from A to B, which is the B voltage minus the A voltage. So if they want A minus B, so VA minus B is just equal to negative delta VAB. Right, cool. And that would be equal to negative 17 volts. Nice. Okay. Okay, so I was correct. I just didn't read this little part correctly. Interesting. Okay, so I feel like that's how you can do that. They do it a little bit differently. They say reference all voltages to the lower left corner. Then VA is 16. And then what is the voltage of B? Let's see how they're doing that. And then they say it's 12 plus 21. Oh, I guess it is. This is actually kind of funny. Okay. This is actually... This is, so, I mean, this method works. And I think it's cool. But here's what they say. Again, voltage is relative to something. It's always like relative to what you're measuring. So they're saying, let's call this, for instance, 0 volts. If this is 0 volts, notice how this connects directly to the negative end of this battery. And then there's the positive end here. That means this is at 0 and this is at plus 12. And then looking at this battery, right? That means this is at 0. This is at plus 16. Okay. Now, if we keep coming across here, right? I know that this voltage difference has to be 21. Notice how this connects directly to here. Anytime you have wires that make direct connections to each other, those are called equipotentials, which means the voltage has to be the same. The currents don't have to be the same, right? I5 is going to be different than I2. But because they're literally connected to each other, they have to have the same voltage. There's nothing in between them. If there was a resistor in between them, then yes, the voltage would change because you'd get a drop across the resistor. But as it stands, the electricity can run straight to here. So this is going to have plus 12 on the bottom. And then if I needed a difference, because the battery always measures the change in the potential, this is going to be 12 plus 21. That's going to make this plus 33. So then, if I look at position B, for instance, right? Position B connects directly to this end of the battery, which is at plus 33 volts. So this is at plus 33 volts. A, right here, connects to the positive end of this battery, which we said was at 16 volts. Again, all referenced to this as 0. Each one of these paths is still referenced to the same, we say the same ground. So then the voltage in between the two, VB minus VA, that's super clever. It's just 33 minus 16 is equal to 17. Yeah. Cool. Or they wanted VA minus VB, I think, right? Yeah. So sorry. So VA minus VB is equal to 16 minus 33, which is equal to negative 17. Yeah. That's so cool. Yeah, I love circuits. Okay, do you guys have any questions about this? Probably.
Yeah, so I tried drawing the direction of the currents on my own.
Yes.
And I'm like, some of them are different from yours. Is that like an issue?
No. Yeah, we talked about that earlier. It's okay. You came a little bit later, but Isaiah brought up, hey, what if, for instance, instead of drawing I4 in this direction, if I drew it in this direction? And I said, that's fine, as long as you're consistent in your equations every time that, for instance, I4 pops out. You need to make sure you're being consistent with the positive and the negative.
Okay.
What'll end up happening if you are wrong is that instead of getting a positive current, you're going to get a negative current.
Okay.
Yeah.
All right.
Super cool. This is a fun question. I love circuits too. Yeah.
Can I ask you about the one to with like the other circuit, the one with power?
Yes. Yeah. What?
Yeah.
Again, it's hard to understand what you're saying over text. So yeah, I was like, yeah, just come to office hours. All right. What's up? You were saying that like there's some way to solve this without doing all this.
Well, I thought so. So
It's okay.
it tells us that the resistor dissipates 0.8 watts at resistor 1, right? The 33
Yes.
ohms. So it's like, if you know the power of 1, and if you know power equals current of 1 squared times resistance 1, you already have 2 knowns. You can solve for the third, or you can solve for I1, in this case is our unknown. And that gets you,
I see. Okay.
so that means you know the current of I1. And technically, if you have resistors 2 and 3 right there, if they are parallel, you make it one equivalent resistor, then that would be in line, or not in line, but in series with the first resistor. So they would have the same current. Yes?
Yes.
Okay, so technically, if the current in R1 would be the same current in R2, R3,
Yes.
then that means the current for R123 is also equal to the current in R1.
Yes.
So technically, now you have the current for the entire circuit.
Yes. So then you need the resistance for the whole circuit.
Yeah, so then you can go calculate the total resistance pretty easily. But
Sure.
Isn't that...
That's fine. I feel like it's the same thing we did here. It's just kind of backwards. So I figured out I1 in terms of the voltage and the total resistance, and then I plugged it in to the same thing. The same thing, right? Power in the first one is I squared R. Yeah, you did this way first, and then you plugged it into this, basically.
Yeah.
Yeah, totally valid. Yeah, sorry, I didn't understand like in text how you're saying it, but yeah. Yeah, that's super valid as well. There's multiple ways to skin a cat, or whatever they call it.
Okay.
Although, like, who's skinning cats?
And whenever we were doing that like pendulum charge question, do you think we should expect a lot of like mechanics to be involved in this final?
Ooh, let me go check. I did just finish writing the final. Let me go check. Yeah, there's actually not really much. Yeah, no.
Okay.
Yeah.
Because I was like, uh-oh, I need to go bust out all my E&M stuff.
You mean your
Not
mechanic stuff?
stuff.
Yeah, no. There's nothing like the mechanics of the pendulum one on there.
Okay.
Yeah.
Actually, since you finished writing the test, can I
So
can
give
I
me the
ask,
topics.
or can you
Give
give
me
me
the
like a
topics.
topic by topic breakdown? That'd be of like
Give
questions.
me the topics. Yeah. Here, let me not show the exam.
It's
All right.
it's over 10 broad chapters, correct?
Yes. Okay. So, question 1 is fluids.
Fluids.
Question-
Okay.
Question 2 is fluids. Question 3 is like sound and music.
Okay. Is that different from like simple harmonic motion?
Yes, sound and music is different from like mechanical waves. I guess was another chapter, right?
Yeah. Well, there's simple harmonic motion and mechanical waves.
Well, I
and
mean, like
sound.
sound and music is like waves at the end of the day. It's like applications of it. Right?
Okay. Yeah. So sound and mechanical waves, I guess I can put together.
Question 4 is circuits. Question 5 is circuits. Question 6 is like currents. Question 7 is mechanical waves. Question 8 is capacitors. Question 9 is circuits. Question 10 is sound and music. Question 11 is fluids. Question 12 is electric fields and electric potential. And then question 13 is circuits. And then there's a bonus question at the end. You'll see. You guys will crack up at.
Okay. Mhm.
So yeah, a lot of circuits. We do a lot of circuits in this one.
All right. Wait, is that last bonus question, is that one of the FRQs or that?
No. It's the last bonus question is not actually worth any points. It's just kind of it's like a fun one. Don't worry. There's no the bonus isn't worth anything.
So 13 questions in total. But
Yes,
like,
you got 6
last-
multiple choice. You got 6 multiple choice. You got 4 numerical, and then you have 3 FRQs that are two parts each.
All right. Okay.
And then if you want the points breakdown, it's on the supporting worksheet. So you can go download the supporting work, and it'll tell you what the point. Because I had to redistribute the grading because we added a couple more things.
All right.
Yeah.
Okay, that gives me a good idea of what I really need to study.
Mhm.
Going back to the stuff you covered yesterday, right?
What's up? Yeah.
Where is it?
I don't think I have yesterday's stuff on here. I only have today's stuff.
All right. Yesterday's stuff. It was like the tsunami question.
Mm-hmm.
So like obviously, whenever it started giving me out like wavelength and velocity, my head went to like wavelength times frequency equals the velocity of a wave.
Right.
It's just, I guess in this question, I didn't know really how to solve it because like, how much time do they have to run to safety? So my head was like, hold on, how far away is the wave? And like, all
Yeah.
that
So
stuff.
there was a little bit of like. Let me see if I can actually. Let me go find the actual question. One sec. It was in here, I think. Yeah, this was it, right?
Yeah.
Let me just copy this in. Right. I calculated the frequency at the end. You don't really need the frequency for this question. But they said, yeah, a tsunami is a pulse right? Whatever. As it approaches Hawaii, people observe an unusual decrease of sea level. Approximately how much time do they have to run to safety? And they said, this is kind of like the key thing here. They say, in the absence of knowledge and warning, people have died during tsunamis. Some of them attracted to the shore when they see stranded fishes and boats. So you have to ask yourself, when would they see stranded fishes and boats? Well, it's when the water level is 0, right? And so that's when you're going to be at the absolute minimum of the wave.
Oh, so that's okay. So when you have the
Don't worry. On the exam, I'm not going to play like this like trickery of like putting things in the words that you have to like figure out. Like, no.
Okay, so that's like, I should take that as like when the wave. Okay, so when
Right, because think about like, how would the boats be stranded? There has to be no water, or like very little water, and so that happens when you're at the trough of the wave, and then we're assuming that you die because like the crest hits you.
okay,
Or we're assuming
so
that like
that's
the wave comes this way, and then the crest is what breaks over.
Okay, because when I saw that 1/2 wavelength, I immediately went to like destructive interference, and I'm like,
Oh
wait,
no. You don't need to go that far. Don't do that. Don't do that. Yeah.
Okay, so that makes more sense. If you only have half a wavelength and you have a known wavelength and you have a velocity, you have how much time?
Very easy to find out time, right? Yeah.
Yeah. Okay, that makes more sense.
Yeah, this was actually kind of a softball, honestly. It's a super easy one.
Yeah. Let's see. Do I have any other questions? For the same yesterday, but like the last question, the Doppler effect one.
Mm-hmm.
So I was kind of confused at first when I was going over this, but it's because the question doesn't say it directly, but it's gonna be like the ultrasound is the source, and then it sends its waves into the blood.
Yes.
And the blood sends it back.
Correct. It bounces off.
Okay.
Yeah. The sound waves. The blood doesn't literally like take the wave and then like hey, here you go. It's because it's bouncing off the blood.
Okay. Because I mean, without looking down at your work and stuff, I would have assumed what would have been like the frequency when the blood is the observer, which I guess doesn't really make sense.
Well, because you need a beat frequency, right? So
Yeah.
beat frequency means that you need to be hearing what you're emitting and also hear what's like coming back.
Okay.
In reality, so this is actually someone like I guess brought this up to me. Technically, you can't hear the exact frequency that you're emitting. So, for instance, if you're like moving and screaming, you technically can't hear that pitch. Like what you're hearing is like the sound like inside of your like, I don't know, your eardrums and your bones and stuff. And I was like, okay, we don't need to get into like biology to like argue about this one. But yes, in order for to be a beat frequency, it's assumed that you can hear what you're emitting and you can hear the difference from what's coming back. And also that this is happening, like whatever you're emitting is constant, right? Because there's also going to be a time delay between whatever you say and like whatever comes back. But if you're constantly emitting a pulse or a tone or whatever, then what comes back, you'll hear the beat frequency. Again, some people overthink these questions because I don't know, maybe you guys are used to professors just trying to like trick you all the time. But yeah, or especially with pre-meds, because I guess the MCAT is just meant to like trick you. They would like get super esoteric about the questions, and I'm like, no, it's not that serious, bro.
Okay. For that same yesterday's question, your first one, when I was going over fluids.
Yeah.
This be like, so I was doing this one and I was like low-key looking at my equation sheet because it's been so long.
Oh yeah, this one?
Yeah.
Yeah, I low-key don't like this one actually. I went back. The diagram they have is honestly kind of shit.
Like once I like sat down and I was like, okay, obviously once I used Bernoulli's equation, I was like, okay, this kind of makes sense.
Right. The setup for it I think is tricky from the diagram. Setting up Bernoulli's equation from this picture is kind of deceiving, honestly.
Yeah, well, because like the position 1 I understood pretty well, but position 2 with it already having like a liquid there.
Yeah.
So I was like, are we, like what, like how much, because I was worried about the pressure on, well, if you do not have labeled 4 centimeters, like the pipe between the top surface of the thing, I would not have assumed that that was the pressure there.
Correct. And don't worry, I'm not going to do this on the exam. This is, I'm not going to like, I won't give you a diagram where this is ambiguous. Also, there is an issue here, which is that as the siphon like works, so as the water level in the sink goes down, this term here also goes down. So in fact, actually, the flow rate is not constant.
Wait, which term?
This second term right here.
Oh yeah, the second term, because
the rho g 0.04. Yeah, because as the water levels, exactly, that's decreasing, and then even more so, right? That would lead to an increase in the term here on the right side.
Yeah, because I was thinking you were. Oh wait, not that term. That's the gravity, right?
Sorry, not that term. Sorry, this term right here. The second term on the right side.
Yeah.
Yeah, because now you'd have more water flows from the left to the right, so you'd actually have more water on the right pushing down, so like preventing it.
Even like assuming like the pipe, for example, that's 4 centimeters below the surface of the water. Yeah. So I guess potential energy when we're talking about position 2 doesn't change.
Right, because it's always the outlet. It's always the outlet, right? Is what we're measuring. But yeah, the issue is that the left side rho g on top would go down, and on the right side rho g on top would go up. And so it would affect the velocity. They don't cancel out.
It also has like a changing, like the cup itself, the pail has a changing area.
That doesn't matter. Pressure is irrelevant of shape, horizontally or whatever. So for instance, if you had I don't know, like some weird ass piece of glass or something, right?
Yeah.
And then you were to, let's say, like compare it to just a straight cylinder like this, okay?
Mm-hmm.
The pressure is the same here as it is here. Pressure only cares about the height of the liquid. It doesn't care about how much liquid there is. Because notice how the pressure term, right, is equal to rho gh for the pressure of the water on top. So it doesn't care about the shape of it. It just cares about density, gravity, height.
Okay.
So even though, right, yeah, you said like, well, wait a minute, the pail is changing area, yeah? Oh, I see. You mean for the next part of the, well, no. Yeah, for the thing that it's like it's dumping water into, I don't care about what the surface area is, right?
Yeah, I was confused because like the surface area, technically it's getting bigger and bigger. So if you have pressure,
but that doesn't affect the pressure.
Yeah, I guess the pressure would be the same. Yeah.
Yes. What it would affect, though, what you are right on, let's say that you know the sink isn't a perfect cylinder. So you see how the sink is like kind of like banked up and whatnot?
Yeah.
For the second question where it says like how long will it take to empty the sink? Okay. But now, right, the amount of water that you're pulling up is changing as a function of height.
Well, yeah, because the surface area times the height would change.
Yes. Yeah.
Okay. Yeah.
So your total volume calculation gets kind of weird, and then like the effect of that whatever that amount of water, yeah, it would change.
Okay.
The height would change at a different rate, yeah.
So like for all those fluid questions, do you think this would be like similar to the kind of difficulty?
Yeah. This is about it. Yeah, it's pretty chill.
Okay.
But not the diagrams won't be as confusing.
Okay.
That's just the textbook, and like I have beef with the textbook over that one because I'm just like, man, this diagram is pretty shit. But it's a cool question. I really like to like show students that you can use this to siphon liquids out of things.
Okay. For a lot of the circuits questions, I'm guessing almost all of them are probably going to be like diagrams, quick. How do you do this circuit? Reduce it down, power, stuff like that. Should I practice that?
Yeah. Get good at reducing circuits. Get good at drawing loops. Get good at solving them. And then also go over when we did like ammeters and voltmeters and stuff, remember how I showed like how those things work? You should be
set them up and stuff.
Yeah, you should be familiar with how like an ammeter and a voltmeter works, and well, also the internal circuitry, like what the shunt resistor needs to be. Is it a high resistance or low resistance?
The shunt resistor is like the resistor at the bottom that.
Well, it depends. It depends on the thing, right? So I think
the resistor is the resistor that you kind of like manipulate, so the actual like ammeter voltmeter doesn't
take too much, yeah. And this is why for voltmeters and ammeters, you have a little dial that selects the range. What that's doing is that's changing whatever the shunt resistor is, because then that changes the range of like currents and whatever voltages it can measure.
How does it change the resistor? Is it like just give it a smaller
it's like the potentiometer I showed you guys, right? You guys remember potentiometer?
It's like making the length bigger or smaller.
Correct, yeah. It's
okay.
Potentiometer like diagram. Or variable resistor. Sorry, I think a potentiometer actually changes voltage, not resistance. Oh, maybe it does. Whatever. Variable resistor diagram. Man, where's like a... I feel like I had a very cool diagram for this. Whatever. Oh. Wait. What did we call it? What was it called? Was it called a thermistor? What was it called? Variable resist. There was a name we had for it. That's gonna bug me now forever, dude. Oh, wait, what was that thing called?
Do you have any like examples of like E&M and like Gauss field questions we might see?
E&M and Gauss fields.
Sorry, not Gauss. Sorry, not E&M.
Oh, sorry. Yeah, no, I know what you're talking about. Like, Gauss's law and like potential
Gauss's
stuff.
law and like charge and stuff like that.
Yeah, I would just be, study how you do it for spheres, and then study how you do it for cylinders. Right? Those are the important ones to know. I don't think I have any flat plates I make you deal with.
Okay, so like pretty similar to what we saw in last exam's FRQ stuff then, I guess.
Yeah.
Okay, that one was interesting.
Right, but you know how to do it now, right?
Yeah, mostly.
Mostly. Man, I'm bugging out. I want to know what that thing was called.
Alright. We're still allowed to use like our like practice problems and like note sheets and all that stuff. Okay.
Yeah, you can use all practice problems, all your worksheets, all your equation sheets, whatever you want to use. Those are all chill.
We can even like use the textbook if we want to look up like a practice problem.
You can use the lectures, man. If you want to go through the lectures, you can do those as well.
Okay.
Yeah. Office hours, you can go through any of
I had
these.
to like recommend, like what should I, between now and when we take the exam, what would you say like are the best, like most valuable, not best valuable, like what's the best bang for my buck stuff to study?
Circuits. I think circuits.
Circuits. Okay, got it.
Look at the homework questions for circuits, and then maybe also look at the practice questions for circuits.
Oh, okay. Practice questions.
Yeah. Practice questions.
Are you talking like just like current resistance and EMF plus direct current circuits, or just straight circuits?
Yeah, just circuits. EMF as well. JC's 25 hours? I've not been streaming for 25 hours, JC. What?
Okay. Alright, look up circuits. What else?
JC, mine says 59. Infinite Dr. Golds.
For our fluids, I think you said one of them's going to be an FRQ. Since fluids was all the way back at like week 1 or whatever, what do you think is like the best things I should hit to study for that?
For fluids, Bernoulli's equations, right? And then also, I would study how like pressure, force, and area are related for different things.
Okay.
So remember, right, that pressure doesn't care about the shape. of the amount. It doesn't care about the shape when we're talking about like the height of fluid that's above to calculate for pressure. However, the force would change though, right? Right.
Well, wait, doesn't pressure?
So pressure equals force over area, right?
Well,
So,
sorry,
for
when
instance-
you're talking about the pressure from like a fluid on top of another fluid or something,
Yes.
right?
Yes.
That's like the dense. It's the density of the fluid times. No, wait, hold on. That's
Yeah, it's rho GH. Density times G times height.
yeah, that's density times gravity times height. So that
Yeah.
gives you the total amount of like pressure pushing down on you from above.
Yes.
And you also have the buoyancy force, which is like it's not. Is
If-
the
if-
buoyancy
if you-
force an
if-
actual force or
It is. It is. Well, no, it's an effect of it's an effect of displacing fluid, is what it is.
Okay, so like, can I like slap F equals ma onto it?
Totally.
Okay, because
But,
I've
like,
always
you-
been confused because like I think I've double
Yeah.
counted in the past, like the pressure from like the force buoyancy.
Yes. No, I remember you did do that. Yeah. Yeah. So, for instance, if you have a fluid, right, and then you have something that's displacing it, or actually,
Yeah.
I should let's make this blue, right, and then actually no, let me fill this bitch. One second. Let me make this like this way. There we go. Okay, cool. And then let's say that you are whatever. Well, let me make this solid. Sorry, one sec. There we go. This is what I'm saying. All right. So let's say you're something here and you're displacing this amount of fluid.
Yeah.
The reason why there is a buoyant force is because if I were to measure the pressure here, let's call this like P1, and let's call this P2, right?
Yeah, the pressure at P2 is greater than the pressure at P1.
Exactly.
Of
So-
that extra.
P1, for instance, right,
Liquid.
is equal to all of the liquid above it.
Mhm.
And so let's call this, for instance, like, let's call this like H1. So that would be equal to rho GH1. And then P2, right, because remember, the pressure here is the same as the pressure here, is the same as the pressure here. Pressure only depends on the height. I don't care where it is. I would say that P2 is equal to rho GH2, all right?
Yeah.
Now, that means there's more pressure here. And let's remember that pressure is equal to force over area. So more pressure means more force. And force always acts perpendicular to the boundary.
The area vector.
Right. Yeah, it acts in the opposite direction. So in this case, the area vector is pointing this way. So the force of the fluid will point this way. So
Okay,
this will, for
when
instance,
I'm,
be
like, making
F2.
Bernoulli's- So if I'm ever like listing out forces and pressures, should I like list out like just buoyancy force and just not?
Oh, so Bernoulli's is strictly for fluid. Bernoulli's does not take into account for this. We don't use Bernoulli's equation for this.
Okay. But if I'm ever like going back to like say our first exam when you had like a cube partially submerged in a liquid,
Yes.
and that kind of stuff, I want to count the buoyancy force,
Right.
but I don't want to count but I'd be double counting if I did like the force generated by P2.
Correct. Exactly. Right. Yeah.
Okay.
Yeah.
That makes more sense.
yeah. The buoyancy, the cute trick of buoyancy force, just being like, in this case, FB is just equal to rho liquid times G times V, comes from this. Because if we were to look at again, this is going to exert a bigger force than the top fluid will push down. And so we could say like F net in this case, which is going up, would be equal to F2 minus F1, which would be equal to rho GH2 minus rho GH1 all over A. Okay? That's the net force pointing up, okay? And then what you should identify here, right, is like, oh, look, this is the same thing as rho G H2 minus H1, All right, sorry, it's pressure times area, right? Sorry, force is equal to pressure times area. So this becomes times A. And now this, H2 minus H1 times A. So, right? H2, which is all the way down to here,
That
minus
becomes
H1.
the volume of the object displacing.
Perfect.
Or no,
This
that
is
becomes the volume of the displaced liquid.
exactly, yeah, because this is H2 minus H1, and then area refers to like this, like whatever the area is on the bottom of the cube. And so that's why, yeah, we just say this is just a trick based on this.
Okay, that makes sense. Could you post this on Campus Wire?
Yeah, sure.
Thanks.
Okay, so I just have a random pedagogical question.
For sure, Isaiah. What's up, dude?
So I'm actually I pretty much finished college. I did philosophy. I didn't do physics.
Okay.
So the first part of my question is like, what textbook should I self-study from, just for out of like interest? You know, I want to do some sci-fi writing.
So wait, you took this course not as a physics major? You just took this because you're like, fuck it, I just want to take it?
Yeah, it's the G. I chose it as a GE.
That's fucking gangster.
But
It's a hard ass fucking GE credit. You could have taken like, I don't know, like underwater basket weaving or something.
yeah, I could have taken physics 10 or an easier
Okay,
class.
cool. Or okay,
Yeah.
I'm good, great. All right. So you like the struggle, cool. But you're saying like, what's a good textbook for self-studying a little bit more to this? Yeah, I guess you said for sci-fi. I love sci-fi, by the way.
Also, I did a little bit of math. I did a math minor, so.
Okay. What's the
I've
highest
done,
level of math you did?
I did analysis up to like measure and integral.
Oh wow. Okay. Like real analysis? You did real analysis?
Yeah, I think I did real. I'm not sure if I did complex analysis. I did real analysis for sure.
Oh, that's impressive. I never took real analysis. We had a discussion on this yesterday. I was like, oh, I took complex analysis, but I never took real analysis. So you took diffie-q, you took linear algebra, you took all those?
I took the lower div differential equations, but
Okay.
it's really not helping. I just don't have the physical intuition. So, like, even
Sure.
when we're integrating charges or something, I'm just like, why does it go from area to like volume or something like that?
Oh yeah, I see. Yeah, some of that actually comes from like Stokes theorem, Green's theorem and stuff. Isaiah's him, bro. So Timothy.
You guys are gonna accomplish a lot more than me.
No, stop. Yeah, I say learning. I applaud that because I say learning knows no age limit. You should, and this is why I enjoy teaching and doing this. And is every day I'm learning something new, and I think that's like super valuable as like a human. So yeah, props to doing this. Okay, but yeah, for textbook, I really like this John Coley textbook. I'll dump the link for you real quick. Where is it? If you're talking about like derivations, right, for like where like Gauss's law comes from and the stuff like that, there is some physics intuition to that, but then there's also there is the math to it as well. I think like Green's theorem and Stokes' theorem kind of explains it.
Do you have any other like fun or challenging textbooks from like your own PhD or?
Oh yeah, interesting. Yeah, here we go. Let me give you. I'm gonna drop some links here first. This is like if you wanted to take, for instance, all of like first year physics. That's the solutions manual, and then there you go. That's the textbook. It's a great textbook. It covers almost like everything. I feel like in first year physics. Like, let me see. It goes from. It even has a little bit of quantum.
That's gonna be fun.
Yeah. So yeah, this is it. It's a lot, dude. I think it's almost. How many pages is it? How many pages is this? Yeah, this is almost 1,000 pages. This whole textbook. But this is, according to like the UCLA track, this is 1A, 1B, and 1C. So like 1A goes to like chapter 9, goes up to like static equilibrium. 1B goes from like fluids up to circuits, up to 19. And then 1C, I think, goes from chapter 20, which is magnetism, all the way to, they do a little bit of nuclear physics, like, yeah, radioactivity and stuff. I really like this textbook. And then a great way to learn physics, because again, you can read, and reading's like chill and stuff, but it never really ingrains into your like neural pathways unless you actually use it. Maybe you've noticed this when like trying to learn a language. You can do Duolingo all fucking day long, but until you actually start speaking to someone or trying to speak to someone in that language, it doesn't really ever like become concrete yet. So I'm a huge fan, and like just go through here, and at the end where it says like problems, just go through these. And I really like this book because it has it always has a chapter called misconceptual questions, and these are questions that are intentionally designed to trick you and kind of like screw with what you think physics is. So if you ever think like, oh, it should go that way, this will be like, no, it doesn't, and then you can go through the solutions manual and it'll tell you why.
Oh wow.
Yeah. So you can do like questions, misconceptual questions, and then problems are like, these are hard. And then especially, so they also rank them by difficulty. So like 2 means it's a level 2, whatever, 3 means a level 3, and then like you can just keep going. There's so much in there. If you want to like, if you have the willpower to self-study, it's great.
Yeah, I tried to get through university physics on my own, but it's slow. It's like 1 chapter a month or something.
Yeah.
It helps to have a teacher, like, then you get like all the exact equations you need to solve it, which aren't exactly in the...
Yeah, rather than like another thing. So yeah, you can read through the book and that'll take forever. Another benefit of doing problems is you quickly realize that there's only certain equations that you really need to know, and that everything else can either be derived on the fly or is just like kind of like accessory. And again, it's the same thing with languages. If you go through like learning a language without being in the country, you're going to learn like all the weird like phrases, all the, sorry, not phrases. You're going to learn all the weird like conjugations, all the weird this, or like the word for like a box of chewing gum. And it's just kind of like useless shit. But then when you actually go to the country, you'll learn that like most people only say like the same 10 things over and over again. And you're like, oh, I just need to know how to say these things.
Yeah, so it really helps me when you with the lectures tell me that. But my question is, what's after like Gene Coley? What's after university?
What's after John Coley? Yeah, okay. So to get into so this doesn't go into what's called like Lagrangian and Hamiltonian mechanics, which is pretty important in physics, and it's kind of a little bit more abstract. It's definitely higher level math. You do things like Noether's theorem and stuff. I'm trying to think who I used for classical mechanics. It's called like upper division classical mechanics. That's a good course. That's a good like book to go through. Fuck, I want to chat. Breskles, did you go through physics? I'm trying to remember what I used for like upper division Lagrangian. Here, let's just ask ChatGPT. It'll probably tell me. Probably tell me which book I used. What would be a good upper division physics textbook that goes over classical mechanics but with Hamiltonians? Goldstein? Okay. Yeah, Goldstein's okay. Yeah, I've heard that name. Let's just see what chat says. I'll probably if I see the name, I'll recognize it. I'm trying to think, like, was Schwinger another dude that used to run this stuff? Ooh, Morin. What were you gonna say, Isaiah?
It was Julian Schwinger.
Schwinger, yeah.
Like,
okay, I think I used Morin. I actually oh fuck, it may have been Marion though. The names are too similar. Yeah, if you want to get into like kind of like the OG stuff, so Landau and Lifshitz, I think make all the physics books. I think Landau and Lifshitz, it's just, so Landau is an absolute G. I think it got a Nobel Prize at some point. But I'm pretty sure they just wrote books on everything. Yeah.
Okay, I guess I'll stick to that thread then.
Yeah, so Landau did all these. So here, let me show you. So he wrote like a book on mechanics, a book on field theory, a book on quantum. He did one on E&M. He did one on StatMech. I don't even know what theory of elasticity is though. But yeah, that stuff's a little bit more dry because it's old school. But yeah, Landau and Lifshitz are fucking solid.
So let's say I'm at like a creative writing MFA, but then if I've read all these, can I just walk into like a physics lab and start doing research, or is that like impossible?
Interesting. Depends the type of research you want to do. So I would say if you want to do, I don't have much experience with theoretical research, and that to me is kind of like magical woo-woo stuff, because I don't really know what people discover by just using like a pen and paper. I'm a very hands-on person. I would say like, yeah, doing research in a physics lab is almost like an apprenticeship. Like you come in as in the traditional track, if you're an undergrad, you would apply to be an undergraduate research assistant. What do they call, like, UGA or something. And you would work underneath a grad student, and a grad student would basically like give you tasks to help them with their PhD. And along the way, you learn like what they're looking into, what they're studying. You learn how to study those things, like how to analyze the data, how to take the data, how to write conclusions. And then when you go to grad school, hopefully you now have enough of an idea of like what type of research you like to do, what type of research you're good at. Then you're the person that's now running the show, and usually you're conferring with your advisor, who's a professor, and they have like a big general idea, because they're the one getting the money for your project. They'll be like, hey, I got $1 million to study. In my case, it was like turbulence and high beta plasmas. So here's an overview of what I wrote in the grant that we want to try to look at. You come up with experiments to go look at it and go analyze data. And so then you would go out into the lab and use your knowledge of physics to kind of guide you into like what things you should be looking at, what analysis you should be running, and like what conclusions you're trying to make. And then you get a PhD basically.
Yeah, that sounds cool. I'll leave it to the professionals. The other part of my pedagogy question is, if you're teaching this to like a kid, like let's say you have a kid, I'm not sure if you're thinking of having like kids.
I say I have 3,000 kids because I have so many people in my Discord, and I'm basically like their father figure.
Yeah, there's probably like a Chinese saying about that, like a father, like a teacher for a year, father for life, something like that.
Exactly. Yeah.
But my question is like, if you wanted to go about teaching this stuff to a kid, like,
how would you do it?
Yeah, how would you do it?
I think hands-on stuff. I've had like really overzealous parents, for instance, like hire me to teach like their 9-year-old kid like classical mechanics. It's difficult because a 9-year-old just doesn't have those connections yet. They probably don't have the math at 9 years old to do some of this stuff. So I would say like if I had to teach a kid this stuff, I would stay away from any of the math because they haven't even gotten to that yet. And unless like they're already like really comfortable with doing, again, simple algebra, maybe a little bit of calculus, then you can start doing that. But if I wanted to get, for instance, like an 8-year-old or a 10-year-old kid interested in physics, I would just show like lab demos, like really cool phenomena that happen because of physics. And there's one woman that she's really good at this. She's from A&M. What's her name? Does anyone know her name? Physics demo professor. She's Russian or Ukrainian or something. She's crazy. Yes, Tatiana. Yeah. I'll win them. Here, I'll dump the link, but and this is the thing that I kind of get bummed, but there you go. This is like, yeah, look, kids, fucking physics. But yeah, like look at this. She's making like marshmallows like expand like crazy because she's dropping the pressure in them.
She averages 50 shows a year on campus.
Send me an email when you get it. So if you want to get kids interested in physics, yeah, like levitating things, this is really cool. Stuff that just kind of like blows their mind, and they're like, yo, whoa, like that's magic, or that looks like AI, and you're like, no, it's actually physics. And if you study this stuff, you can come up with other really cool things. I think that's the best way to like inspire curiosity to physics.
Okay, thank you so much for all this.
Yeah, for sure, dude. Yeah, she's fucking great. What's up, Jack?
Yeah, but if you have like any like Gauss's law or like questions on hand that like you were looking through but decided not to put in the exam, could you go over that? Because I just like,
you're asking me to dance around to like to tell you what's not on the exam so you can figure out what is on the exam.
Well, I mean, like what's like I want to practice like Gauss law and like the electric charge stuff.
I got you. Yeah. Okay. Here, let me go through Kudu and let me just like tell you what I think you should cover.
All right.
All right. Electric potential. Let me see. Questions. Okay. Yeah, like I think question 5 in the homework. This was good. You know, like doing some. Yeah, doing some potential between spheres. Let me see. We already with like cylinders and shit. Some cylinders. Bro, where are my cylinders, dog? Mathematician. What's up, dog? Oh man, there's not really many homework questions on this. Wait, we did one. Didn't we do one with Emily? It was like the potential difference between like 2 infinite lines of charge. I feel like that was a question. That was a really cool one. I like that one. Try to remember where she did it. Looking through it. Mathematician, chill, dog. Chill, I'm helping out students first. And if you submit a JEE question, I'm not doing them, dude. Just don't do them. Oh, this is it. Yeah, question 6.
Solid cylinder conductor.
Yeah. That's another good one. Yeah, question 6 is good. Yeah, just getting comfortable with like what the electric field and the electric field and the electric potential are for different geometries. I think I only go over like spheres and cylinders. And then knowing that if you want to figure out potential, it helps to just get the equations for the electric field first, and then being comfortable with integrating that.
Okay.
Yeah.
All right. Thank you very much.
Okay, you're cool, Jack.
All right. Then I think that's all my questions for now.
Okay. Let me see what mathematician's yelling at me. Aviv, what's up? Do you have anything else you want to ask about? I'm not pressuring you.
I had another one about like circuits.
All right, let's do it. What's up?
When you have like there are some of those homework ones where you have like 6 resistors and you try to simplify it.
Yeah.
I know I read, I think it was in like the pre-lecture that was like you want to do the parallel ones first and then series after, right? Or is that?
Yeah. In general. No, it doesn't matter. I mean, it does. So yeah. So for instance, if you had something like this going into this, I like to think about it as, again, those Matryoshka dolls, whatever they call them.
Yeah.
So I can't put this in series with this yet because this is in parallel, right?
Right.
So you see, I'd have to do, okay.
Yeah.
But, what if I had this, right? Now, I can't put this in parallel until I put these in series.
Yeah.
So it's like you're whittling down to like what's the simplest circuit I have, and then you're like coming back up.
Yeah. Do you think you could pull up one of the ones from the homework where it was
for sure.
You had like they gave you the EMF and they gave you like R1 through R6?
Yeah.
On the most recent homework.
Was it this one right here?
I mean, yeah, that one's good. Or like there's the ones where it's like some of the wires are like slanted or like diagonal.
Oh yeah, I like those. Yeah, those are good. You're talking about like this shit.
Yeah. So yeah.
Ooh. Okay, what is it asking for? Find the value of a single equivalent resistor. Oh, ew. Okay, fine. Yeah, let's do this one.
Like I think when I was like doing these problems, I got them after a while, but it felt like I wasn't doing some like standardized. You know what I mean? Like I feel like I was like.
Yeah.
doing a different process each time. I
Yeah,
was wondering if there's like a standardized way that you would go about it.
You have to like eye it. Again, this is one of these things where
Yeah.
it's hard to like teach. Because some
Right,
people
it's
just
kinda-
like naturally have the spatial like recognition for it. Other people, you need to do it a couple times before you get it.
Yeah.
I don't know what camp. I think I fall into the camp of like I just understand this, but okay. I like to look at, for instance, if I'm coming from here, like what's happening, and I'll draw things as straight lines. So, for instance, if I'm doing this, right, I know that I have a positive end here, and that's going to be going into like RA. Okay, cool.
Yeah.
And then that's coming here, and it's splitting, right? This is a juncture, right?
Yep.
So now we can draw that this thing is split. When things split, they're usually doing things in parallel. So let's kind of see what happens. So I have this, for instance, which, whatever, we can say that that's going to be like this one. We have this one. Then we have this one. And then technically we have another one. We have this coming back. I think the one coming back is like what really fucks things up. Because I think it's pretty easy to see. Do you see how like this and this and this, these are all in parallel with each other, right?
Yeah.
Right? Yeah, okay. So if I wanted to do just whatever, like this, right? And then this. And then... Because here's the thing. You can always move, like, points as long as you don't cross over junctures. Okay, so, like, for instance, I can move this whole juncture here. I can move it to connect with this one. As long as I don't move past it.
Oh, interesting. Okay.
Right? So, in reality, this ends up looking like, yeah, RD. But then that's in series, right, with RE.
Yeah.
And then that's also connecting to the same endpoint for RC. And then that's also connecting for the same point for RB. So here's the other thing. Like, as long as you don't... as long as you don't, like, go over more components, you can kind of, like, draw them on the same line. I guess I kind of violated a rule here, though, right? Because I'm crossing a juncture. Yeah, okay, so here's the issue, is that... Alright, so those do connect. But then... Oh, man, this part's a little tricky. Let me think. Okay. Well, this connecting to the end of this still connects to the end of this. So I could draw this part, for instance, connecting all the way to there as well. So I can say that...
the same wire?
Yeah. So I can say that this right here, for instance, is RF. And that's eventually connecting straight to the minus sign, right?
Yes.
Okay. So then this is minus. This is positive. And the little tricky bastard here is this thing. Okay. Let's think. So that connects from the end of here. So, okay. The end of the red. Oh, straight to here. Oh, so that's another... Is that another parallel then? What do you think? Oh, wait. Okay, wait. Yeah. Yeah. Okay, so here's kind of the funny thing. All right. Let's call this, for instance, like the positive side of RF. And this is the negative side of RF, right? Because this is connecting to the battery.
Yeah.
See how this is the positive side? And the positive side connects, again, it connects to the end of RB. This can also help you to write like positive, negative. Okay. Let's do positive, negative. Yes, mathematician, I can say whatever the fuck I want. Chill. Positive, negative, positive, negative. This is positive, this is negative. This is positive, this is negative. Okay. So you see how the negative ends of all these resistors connect to the same point?
Yeah.
Right? But then that connects to the positive end of RF.
Yeah.
But then the other end of RF now connects to the negative end of the battery, which is nice. So then let's look at RG here. RG has this positive end, right? Connecting to here. It has a negative end here. And so this positive end of RG connects to the negative end of RA, which is the same thing these things are all connecting to. So this right here is RG. And then instead of it connecting to here, it bypasses all that and it connects to the negative end of RF. So this goes to here. So you see how like this end, right, doesn't connect to my. Let me make this like a different color. Let me like color the junctures. I think if I color the junctures, it'll make more sense. Do you see how this becomes the hub for?
Yeah.
Right? The minus of that.
Yeah.
The minus of that. The minus of that. But then it's the plus of the green.
Yeah.
And then, yeah.
So that'd be in series.
Yes. Yeah, so, and then this is, for instance, right here.
So when you have, like, the positive to positive and negative to negative, like when they share those endpoints, that's saying that's parallel.
Yes.
And then, yeah, because that would make sense. And, like, negative to positive is, like, head-on is how you know it's series.
Oh, good. Yeah, that's another way to think about it. Yeah, totally. Yeah, right. Yeah, if you have, right, something that looks like this, I don't know, let's say it connects to a battery like this, then yeah, this is positive, negative, positive, negative. In reality, what happens is, if this was, like, for instance, 12 volts, it becomes like, I don't know, like 8 volts, 4 volts, and then like 4 volts, 0 volts. So technically, it's like, this is the higher side of the resistor. This is the lower side. This is the higher side. This is the lower side. But you're dropping 4 volts every time and eventually get to that. Yeah.
Makes sense.
Yeah.
Cool.
Yeah. Yeah, this is a cool one.
Thanks.
So what would this be? This would be parallel, 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 and then all of this is in series with that, and then all of that is in parallel with this.
Yeah.
Wow. I know. It doesn't look like that from first glance, right? Like, you look at this, you're like, what the hell is this thing?
Yeah, and all that is in series with A.
Oh, yeah. Forgot about that, too. Forgot about it. Yeah. Jesus.
Yeah. No, it's fun. It's like a puzzle.
Yeah, dude, this is why I love circuits, dude. Circuits is so fun. It's like, yeah, a little puzzle.
Yeah. By the way, I was the same guy that in the chat today I said, like, I had work all summer, and, like, this is the first time I made it to lecture.
Oh, good.
Yeah. That's why
Congrats
I wish
on
I could,
making
like,
it.
go to the, like, I love watching all the lectures and, like, the sound effects, and, like, I wish I could go to the office hours more.
Yeah. It's all good.
Yeah.
You got life happening. I'm glad you came by and got to see it live.
Yeah. Life-changing experience.
That's dope.
That's dope.
We love that. Life-changing
Yeah, I
experiences.
appreciate it.
Yeah,
So
for sure.
Yeah. And so you said you do, like, so you have, I saw, like, the office hours, like, calendar. You do, like, so after, say, like, you are not teaching a UCLA course, like, what does your office hours schedule look like?
So usually it's, man, I gotta remember, like, what, it's usually, like, Monday, Tuesday, I think it's Monday, Tuesday, Wednesday, Sunday. I think it's usually when I stream. That might change because my life is also kind of in flux right now.
Sure.
I don't know, like, I have another job, and it's like I have another tech job I work that, like, pays my rent and stuff. But it's like one of these startups, and things are changing, and I don't know how much time commitment I need and stuff. But But yeah, I try to stream at least 3 times a week, sometimes 4 or 5, depending on it. But yeah, the schedule here is always the regular schedule. And usually what I'll do is, this is usually my time I will stream.
Yeah. And so those streams that you do are like open to anyone and anything?
It's like this. Yeah, you see how this is like, I mean, this is technically, this is open to anyone, but...
Oh, interesting. It just
but
happens
if you,
that your students...
yeah, well, I give UCLA students priority because it's one of these things. The university forces me to have office hours, but for the first like 3 fucking weeks, dude, no one shows up. Like no one needs help.
I really would have.
No, you're good. You're good. But a lot. It's not, I'm not blaming you or anything, but I understand how it works. No one really needs help till the end, anyways.
Until the exam.
Until the exam, exactly. Yeah. So what I do is I already do this anyways through like my nonprofit. I already host open hour. So during the beginning of the year, I still let whoever my web viewers are like just ask whatever, and I'll work through questions. But then now that you guys need help, I give you guys priority. Yeah.
Got it. That's really cool. I appreciate it.
Yeah, and I'm not the only person that does it. So like, yeah, if you need, I don't know, what's your major? What's your plan? What are you trying to do?
Yeah, so I'm applied math, going into my second year, and I want to work in like data analytics. But I'm really like open to a lot of things. Like I'm not sure on that, but I feel like that's where I'm headed right now. Cool. So this course is after this and after 33B, I'm ready to start upper divs. So
what is 33B again? Sorry.
Differential equations.
Okay, DiffyQ. Nice. Yeah. I like DiffyQ. I think DiffyQ is another fun like puzzle type math question. It's super dope. We were doing a lot of DiffyQ so during what was it, yesterday's office hours, Jack and whatever didn't show up for like the first hour, so I was helping a student out with differential equations. Cool. And so running through that. So yeah, if you need help with DiffyQ like during the school year, I'll still be here doing this. And so you definitely do. Yeah, feel free to tap in. Yeah. It'll be hosted more on I won't have like this Google Hangout link, but so I stream on Twitch, YouTube, TikTok, everything. So just find me on one of those channels. Yeah, TikTok as well. I do TikTok live as well. Yeah, it's funny.
That's sick. That's actually sick.
Yeah.
I brag about you to my friends. Like whenever there's like a funny clip from lecture, I like send it. I'm like, look at my physics lecture.
I gotta hire some clippers, dude. I gotta hire some clippers to make some fucking cash, dude.
You would actually go viral. It'll be like UCLA professor goes viral. I was like,
yeah, I'd probably get fired like the next day once I blew up though. They'd be like, this is a PR nightmare. We need to get rid of this.
We need a good PR team.
We need fucking PR, HR.
And then like, so I saw on that calendar there's like real analysis. You said you didn't study that. So it's like another tutor.
Yeah, so this guy's named Penn Center. He's a professor. He was dean actually at it's a smaller college in Canada. But here's the other cool thing: if you click on any of these things, I coded this with like ChatGPT or whatever. Very cool. But this is his channel. Like chat. Oh, I can't hear myself. Okay. But he has, I forget if he's recording his videos. Yeah, here we go. So this is his Twitch channel, and so he's been doing real analysis lessons throughout the summer. So you can hop in these live and ask questions or see what's going on. A lot of this stuff is organized also through Discord. So I have a Discord called Actual Education. The link is there as well. Again, feel free to join it. We got like 2,000 kids in it. But we do a lot of stuff. We do like chess tournaments and like people like, I don't know, talk shit and other stuff. But we also organize things. Like for instance, Zach here, he's Eat the 2i Pie. He does like, for instance, he'll run like a DiffyQ class during the year sometimes. And so, yeah, and there's like a curriculum and stuff. It's all free. Like this is all just like us nerds who just love to like teach and shit. So
really cool.
Yeah. So feel free. That calendar updates pretty regularly. And if you see, for instance, if you need help with math and it's like a math ed Q&A channel, these are great channels to come ask questions. And then some of the other ones, I guess Penn Center is also doing abstract algebra, so you can go learn abstract algebra with Penn Center as well. I don't have time for this stuff, but
yeah.
Anyways, yeah, it's cool.
Awesome. Well, I appreciate you, Professor.
For sure, Aviv. Cool, man.
Thank you, man.
Stick around and like whatever during the year and say hi. And we'll still be here.
Definitely will. Yeah, thank you for a great summer, Professor.
You're welcome, dude.
Definitely got me tough. Like, I feel like 10 weeks is already a pretty short time for this content. Like, condensing into 6
It's nuts.
I appreciate
Yeah, it's insane, dude. I feel like I just went through like a bender. I'm just a bender of education.
Oh no.
Yeah.
Oh yeah. Nice. All right, man. Take care, Professor. Thank you.
You're welcome. Good luck on the final, dude.
Appreciate it.
All right, what's up? We got 18 minutes left. All right, mathematician, I'll go take a look at yours. I'll do your question. I have to help my students. Gotta help my students first. Apparently, I was the highlight of their summer, life-changing experience. That's pretty fucking cool.
That's dope.
Haven't heard that one before. All right. First, before let me save this for the kids. Do you charge your UCLA students for doubts and sessions? What are doubts? I'm sorry, what? Excuse me? What's it? What are doubts? Oh, I gotta like move. One sec, I gotta move this. Oh, doubts are questions. Oh, okay. I see. That's like a translation thing. All right, totally cool. No. I mean, I mean, they already pay like thousands of dollars to be in this class. I see like a very small percentage of that. I have my own gripes about the financial model that this is. Because I think I have like 130 kids. I'm pretty sure they spend close to $3 grand for this course. So you do the math, right? 3 times 130, it's $390,000 that UCLA just takes in. And then like, what are UCLA's costs to teach this class? Well, there's me, which they give me like 8 grand. So I'm like, cool. But then there's no other costs, right? They don't pay for a classroom. They don't pay for my electricity. They don't pay for my internet. They don't have to pay for any facilities. There's no janitors. I would love to have a janitor come by my place.
My man.
So it's just pure profit for the university. Yeah, the summer courses are a hugely lucrative moneymaker for the campus, which is why they'll reach out to someone like me who they don't have a contract with. Like, I'm not on salary. I don't have health insurance through them. And they're like, hey, do you want to teach this? And I'm like, yeah, I mean, not really doing anything else this summer. Sure, and it's good to keep my tools sharp, I guess. My teaching skills sharp. Helps with the resume because I can say like I've taught blank number of courses. And I enjoy it. Like, I enjoy teaching. So, yeah. Is it mandatory to join your course? No. Dude, the summer is 100% not mandatory. The summer is elective, which means it's optional. Students do it because it's a way to squeeze in more classes and either like graduate college early or be able to like take some other cool stuff. Or in this case, to get a really dope professor.
That's dope.
Like, if you see a certain professor's teaching over the summer, sometimes they'll be like, oh, yo, I want to take a class with that guy. He's cool. Because trust, like, some of the physics professors are absolutely nightmarish. And actually, UCLA is like trying to fix their reputation. Like, the undergrad physics classes are notoriously brutal. So yeah, it's totally optional. There are no summer scholarships. That's not a thing. Summer is pretty much exempt from scholarships. They just want to make money. You don't have to go to summer courses. Also, to not become totally retarded over the summer. Yeah. Correct. That is very true. Yeah, otherwise, yeah, it's like a use it or lose it thing, man. Yeah, if you're not using your brain every day, you start losing it. Let me post the office hours for the students. All right, so let me rechat. The real crime is that the students are overcharged. It should be free for them, and you should be paid more as an instructor. Yeah. Unfortunately, like, yeah, there are costs. Like, I know UCLA needs to pay people to, I guess, run their website or, like, deal with admissions or, I don't know. It's just, it's kind of weird when so much of the money coming in through my service doesn't even really go to my service. It goes to other things. It's like paying taxes, I guess. Like, if I pay X amount in taxes, like, can I determine, like, how much of that went towards, like, actually fixing the roads that, like, I use versus how much of it went to, like, building more bombs? Or, I don't know, like, bailing out, like, corporates, whatever. I appreciate that, mathematician. Search me some students as well. I can go for maths. Do you interact with every student in class? Some students are shy, not too talkative. You know, and honestly, it's something, mathematician, that's gotten, I would say, like, worse over the years. When I first started teaching, in person is obviously easier because, like, they have to look at you. Like, you're there. But also, I guess online is sometimes easier because students have anonymity, right? They hide behind screen names and usernames. So sometimes it actually helps. People are more talkative online. But in general, as time has gone on, yeah, I have noticed a significant decrease in, like, interactions. I think what's happening is more and more of the upcoming generations got hit harder by COVID because it was during an earlier formative period in their life when they were developing social skills. So, for instance, if you had already, like, if you had already graduated from college and then COVID hit, it didn't really cap your social skills very much because you're like, okay, I already went through, like, the best social experience ever, which is college. But then, like, if you were in college while COVID hit, that's going to kind of put a damper on things. I feel really bad for the students that were going into their first year of college with COVID. Oh, man, that sucks because, like, first year of college is so impactful. It's such a transition, and for that to be, like, slammed into, like, you got to stay at home with your parents and, like, do things from a laptop. Ew, gross. But then progressively, right, as people get younger and younger, so high school, middle school, whatever, it, like, maybe, you know, late elementary school, going through COVID then, when you're really, like, building up the ability to, like, to talk to people, to ask the teacher questions, to build up confidence, that I think starts having a big effect. And then there's kind of a reverse thing where, if, for instance, you were an infant, so if you were, like, 1 or 2 years old, COVID was actually a good thing because it forced your parents to be at home with you. So you actually got more interaction than most kids got with their parents, because most parents these days need to work jobs in order to, like, sustain an income that allows them to pay rent. And so, yeah, there's, like, a sweet spot probably of, well, I would say sweet spot. There's a big red spot of where I think COVID hurt people the most, and I think we haven't hit it yet. And I'm seeing the effects of it. It's getting worse. I'm seeing that the students coming in, also with the advent of, like, social media becoming more prevalent, AI, all this other stuff, whatever you want to call it, there is a downward trend, and I have noticed significantly in the last year or two that less and less students want to interact, like, one-on-one or, like, express their feelings and stuff. Do I have any Indian students in my course? Of course, dude. Yeah. Dude, you want to see my roster? Well, I can't show you my roster. It's private information, but I have so many, like, Shri Krishnas in my class, dude. Yeah, I have a lot of Indian students. They exist for sure. Anyways, how many Patels? Yeah, a lot of Patels probably. I would pull up my roster, but I can't do that.
You done
Oh no.
I just don't even want to risk that getting shown because like that would be like bad. But yeah, social media. I agree, Femvox. Social media has done a lot of damage. It does a lot of damage, I think, because a lot of people use it in the wrong way, and the algorithm pushes things to be like kind of harmful. It's the reason why, I don't know, record number of girls are having body dysmorphia problems is because it's just slammed in their face of like, you need to look like this beautiful, and it's like it's unachievable, it's unattainable. And at the same point, you know, guys, I guess, are giving up on dating and stuff. There's so much like just like really shitty stuff that's happening because the algorithm loves to reward like rage bait. It loves clicks to the point like even when you go to comment on like a popular post, the other comments you see will be different based on what your interests are. So if there's some video about I don't know what's a controversial thing these days, fucking everything. Let's say I don't know, like the war in Ukraine or something, and someone's talking about it. If you're kind of pro for it, the comments will be like, yeah, we should give more money to these people. What are they doing? And like, if you're against it, the comments will be like, yeah, no, we need to fix what's happening at home. So your echo chamber gets like reinforced because the algorithm knows you'll interact with that, and you'll click it more, and you'll stay on the platform more, and then whatever, Jeffy Bezos will be able to sell you more shit.
Oh no.
It's all terrible, but there is some good to it. So that's what we do here. Is I know the algorithm will find me people who need help in math and science because that's what my content provides, and it's why we do pretty well on the shorts reels during the school year. And then there's some other people like again, there's all these other streamers like Zach and Penn Center and Dawn, Obi. There's so many people that we raid the people all the time, right? Nerduino, Shark Geek, Moohoodle, Science. There are a lot of people that are trying to put out good information on social media. It's not as many. I love this girl, dude. Tiny Toxic Tofu. Where's Tiny Toxic Tofu? She's great, dude. Yeah, this girl's like fucking awesome. I did an interview with her once, actually. I was on her show for a podcast. But she does a lot of physics and like circuits and stuff. Look, this is her doing all of like Maxwell's equations. She's super cool. And so social media can be used for good things. I just think far too often it's used for bad things. But yeah, I know we're wrapping up soon here. I wanted to make an announcement that, yeah, I'll look at yours, Mathematician, for the end. Is that we do have games on Friday. So actually, let me change that on the calendar because it's a chess tournament. We're gonna do a chess tournament on Friday. Here, I'm gonna say chess tournament, and then let me put the information in there. Actually, that's probably a smart idea. I should have done that. There we go. There, so if you click on it, now there's a link to it and stuff. I feel like. Okay. Well, this should update eventually. Yes, chess tournament. There we go. Cool. So yeah, we're gonna do a chess tournament tomorrow around the same time. Come on by if you want to come play chess. If you're good or bad, doesn't matter. The only way to get better is to play. And then we'll give out we'll do a giveaway prize for anyone who participates. You play chess? Come on by, Mathematician. Have you ever competed in one of our chess tournaments? They're super fun. We do them on chess.com. But here, I'll dump the link for you if you want. No, dude, Fembox, you were totally what you were saying is 100% valid, dude. Don't worry. I love what you were like, oh, Jesus Christ. It's totally fine, dude. It also like tests my patience to and you can tell that, like, bless Jack. I love Jack. He asks a lot of good questions and stuff. But you can tell, like, towards the end, he's like, which questions should I not study because they're not going to be on the final? And I call him out.
Oh
I'm like, no, dude. No, you're just trying to ask me what's on the final. Like, you can't do that. Yeah, Breskel's is like, valid crash out. It's okay. It's cool. I don't blame it. Because these students are under a lot of pressure to get good grades. Especially if they're like going into med school or any sort of like competitive thing. They're probably juggling a bunch of classes at once, especially if they're taking this course over the summer. It's intense. I do not recommend this to anyone. The course I teach, I don't recommend people to take. It's intense. So what their brain has to do to like deal with that is to like always subconsciously try to find a way to optimize getting the good grade. And sometimes, that is just asking like, hey, what's on the test? What's on the test? What's on the test? I know why they're doing it. It's just natural. And it's fine. I mean, I get it. But I get why it can also be like really annoying. You're like, yo, stop. Yeah, of course, Femvox. Yeah. That's the problem. Yeah, don't hate the player, hate the game. That's completely valid, dude. Completely valid. Is there a prize for participation? Yeah, so mathematician, as long as you show up and play games, you get entries into the giveaway. If you win games, you get more entries. And then at the end, I do a little spinner wheel, and someone randomly will win like $10. So, come on by. Yes, I agree. Yeah. Well, yes and no, Breasticles. The issue is that, so it's not only their fault, it's also, there are some professors, for instance, that will say one thing about like the homework and the lecture, and then they throw an absolute curveball on the exam. And then the kids just get like screwed. They're just like, yo, what? We like never went over this, or like it was never on the homework, it was never covered in lecture. And sometimes it's the professor just trying to be, I don't know, like a try hard. They're just trying to see like who's the best person ever, like who's the next Albert Einstein. So they just put ridiculous questions on their tests to like try to test for the savants. I abhor doing this because it pushes people out of physics because they feel like they're dumb. They feel like they can't do it. Because some like, I don't know what the word for it is, but yeah. So, some professor is just like, just going, woke up and chose violence in the morning. Do I trick my students? Not very often. I don't like to trick my students. I will put things that trick AI though. So for instance, I will put things on the diagram that AI would screw up. Nowadays, AI can literally get through everything, but whatever. Sophia says, do you teach during the school year? Formally, I'm not scheduled to teach, but I do host these office hours throughout the school year. We've been doing this for 5 years and some change. Like 5 years and 4 months, I think. Here, actually, I think Fembox, you asked, right? You wanted to see, like, what's the total amount of time I've streamed? I think I can find that in my dashboard. Or actually, it's gonna be, one sec. It's gonna be in, it's under achievements. Yeah, here we go. Okay, here we go. Stream. Okay, so it says I've streamed for 1,600 hours. 1,614 hours. It's the total amount of hours that I've streamed. Yeah, almost 2,000. 1,600. That seems a little low, but okay. But then, yeah, I always love the watch time. Those are always kind of fun. Yeah, so almost 15,000 hours of watch time. That's cool. I would like to make partner. This is kind of like the next step. I've been stuck on this probably for the last 4 years. The issue is getting an average of 75 viewers. It's super hard, I feel like, to do on like a tutoring help. sight. If I was just sitting up here and just talking and blabbing and, I don't know, showing my feet or something, I could probably get it. But I don't think that's really my goal with this channel. My goal isn't to become like a personality. My goal is to like help people and really like enable other people to help people. So I'm not as concerned as like hitting 75 people watching at once. Sophia says, I really enjoyed your class. Thanks for teaching. I think you mentioned something about driving S2K. Yes, I love cars. I'm a big fan of cars. I have a couple of them. I actually have 3 cars technically. Yeah, I'll show you my S2000. I just put like $4 grand into this thing. I was fixing like the suspension and everything. But yeah, this is my S2000. This thing's a dream. I love driving this car. I actually, I took it to like, I went to a special shop. It's called Evasive Motorsports. They're a really, really cool company here in Southern California. And this is what they call like the S2000R. This is like a custom S2000 they spec'd out. I have a 2004 AP2. So it's the first year of the AP2 series. But there's no traction control. And I think it's still like manual steering and stuff. I don't think it's drive. I think it's like drive. What is it called? Drive by wire or something? Or like the throttle. The throttle is an actual cable as well. So it's pretty cool. The other car I own is this big van here. I have this big 15-passenger van that I use to like transport equipment and stuff. It used to be my family's like church van because I had 5 sisters. We're a really big family. And then my daily driver. So the S2000 used to be my daily driver. And then gas started, because it takes premium, gas started getting expensive. And also it's a 2-seater. It's incredibly like inconvenient. So this is the car I drive now. It's a Ford Maverick. It's a hybrid pickup truck. I even got I had to get the custom gold life plate on it. Also, it came in like kind of a gold color. They call it cyber orange, but I was like, oh, I need that car. But I love that car as well. It's a great, it's great for like hauling equipment. So this is like me taking speakers and stuff to the beach to go throw a big party. And so it's a pickup. It can seat 5 people, and it's a hybrid. And MSRP when this thing started was like $20K. It's now up to 30. But yeah, I hopped on it real early when it was cheap. Great car. Yeah, very cool. You can make your friends join the stream. That's cool, mathematician. Maybe we'll do a partner push. It's pretty intense though. It's 60 days and you need 6 streams with an average of 75 users or more. It's pretty hard. Yeah, am I based in LA? I am. Yeah. I live right next to UCLA. I'm in Sawtell. I know about Angeles Crest. I don't think I've run it before. Don't like people like die there. I've done like Mulholland a little bit. I've done the canyons. There's a very pretty point up by Malibu I've driven. But yeah, Angeles Crest I've heard of. And I think that's a very famous one that people go by. Like Jay Leno shows up and stuff. But there's also like some very infamous accidents there. What about the place Bosch lived on in his show? I don't know. Who's Bosch? Who's Bosch? Oh, okay. Oh, yeah. Oh, this one. Harry Bosch from House. Oh. Yeah, this is the Hollywood Hills. Yeah, this is a little bit... I've been here. Like, I've thrown parties in the hills. It's about, like, 30, 45 minutes for me. Am I currently working on any research? No, not particularly. My PhD is in plasma physics, and I kind of stopped doing research on that after I graduated. I did a postdoc for like 6 months. I did a little bit more research, and then kind of chilled from it. And then yeah, I focus just fully on teaching and education at this point. There is like education research that I could do. Have thought about that. I did go to this And yeah, mathematician, don't worry. Let me do your question during the next office hours, just because I'm like kind of running out of time. But I went to this thing called AAPT. So it's like the American Association of Physics Teachers. APS was there as well. APS is the big physics thing. And these are my friends actually. And look, they were doing this was a poster session. I ran into them, and they did measuring student response to research-based student success curriculum. And it's cool. It's like they're doing research on like how students learn physics. This was another really fun one I saw. A kinesthetic activity for learning quantum measurement. So they're like here they're showing how like a wave function like collapses in like to another wave function. And they're like, hey, maybe this is a way that we should teach quantum. Like, this is so cute. This was the other big one, dude. Man, I saw this on someone's board. And this has actually kind of inspired me, like why I do physics. They were looking at how undergraduates work with like tutoring and different assistants, and this graph like really spoke to me. It said forms of physics help used by physics students. So 64% used study groups, 47% used AI. Dead last year was professor office hours.
Oh no.
Only 15% of students actually go to office hours. Again, that's the whole reason this stream is called office hours, is because I myself also never went to office hours, but it's like the one thing I wish I'd gone to more. And I understand why I didn't go. A, I was like hungover most of the time because I was just partying in undergrad. And then B, I was also afraid of the professor thinking I was stupid. I didn't want to ask questions because I didn't want to like expose myself as being dumb. And that's a really silly thing. Like, professors never think less of you for asking questions, no matter how simple they are. I mean, as long as your teacher's not an asshole, like, I won't think less of you. I know some professors are, like, particularly Russian, is what I would say. Like, they're old school, and they come from a time period where, you know, if you didn't get the math, you went to the gulag. So they have, like, a very low tolerance for not getting things, because they're like, you need to get this. If you don't get this, like, you know, bad things will happen. And so, but I myself, I try to encourage my students to come to office hours, and that's what I hope to show with this stream, is that office hours is a great way to learn, and you should go do it more often. Yeah. And yeah, that was the convention I went to, Fembox. Yeah, AAPT. Bro, my question only takes 3 minutes. All right. If I can solve it in 3 minutes, maybe. I don't know. Do I have any other information here? Oh. Wait, I think I have to start drawing things, right? Maybe? This is where you like draw auxiliary lines. Oh. Oh, ooh. Maybe. One sec. I think I got it. Yeah, I think I remember. What's up, Jeff?
My name is Jeff.
Yeah, I think this is what it is, right? So from the center to here, this has to be R. This has to be R. And then this also has to be R, right? So then this right here is R minus 1. Right, if it's the center of a circle. I think we assume, right? I think I can assume that, right? Yeah. Somewhere on the center of this somewhere in the center of this circle is a point that goes to here, also goes to here, also goes to here. Looks good so far. Okay, cool. So then, find the area of the triangle, multiply it by 4. Yes. Is Kudu taking interns? I don't know. You can try emailing them, or I can talk to them maybe. They're kind of a smaller operation right now. But You guys definitely stress tested it for them. Yeah, I don't think you multiply by... Well, you could multiply by 4. You're saying multiply this triangle by 4? I think what I want to do is... I know that the area, right, is equal to base times height, which is going to be equal to 2 times r minus 1 times whatever this bit is. Right, times like let's just call this c. So 2c. But then we say that whatever c squared is equal to r minus so c squared plus r minus 1 squared is equal to r squared. Right, from this right triangle. So c squared plus r squared minus 2r plus 1 is equal to r squared. So cancel, cancel. So c squared is equal to 1 minus 2r. Ooh, I still don't have area. I still don't have r though. Bum 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 bum. Watch my signs. Watch my signs, he says. Oh, yeah, my bad. Yeah, sorry, that moves over. Sorry, it's equal to 2r minus 1. Yeah, you're right. Oh. But wait a minute, this is also r. Oh no, wait, what? Wait, how can that be? Oh. Oh, okay. So sorry, it's not... Yeah, okay, sorry. It's r times r minus 1 times 2c. Right? Yeah, I think so. But still, it's just in terms of r, no, dog? Right? Wait, this is r. It's r minus 1. Oh. Sorry. No. It's equal to r minus 1 plus r times c. Okay. Oh, okay. And so this is 2r minus 1. Times c, but c squared is equal to 2r minus 1. So then that's 2r minus 1 to the 1/2. So it's equal to 2r minus 1 to the 3/2. Where's that last little bit though, dude? How do I fucking get r from this? Femvox, have I solved it? I still need r. That's so close. How do I get r from this? I'm getting distracted by this irrelevant triangle. Is this the irrelevant triangle I'm getting distracted by?
Emotional, damn it!
I am, aren't I? He says, you're so close, dude. Oh. No. No. Wait, it's a square. Oh, so I only need one of the sides, right? Oh, so actually this doesn't make sense. Yeah, exactly. Thanks, Jeff.
My name is Jeff.
Dude, I was like, yo, excuse me? Yeah, wait a minute. This actually doesn't make any sense. Yeah, wait. How can the height be different? Oh, because it was 2C. Okay, yeah, let's stop with the triangle garbage. Okay. So the side is equal to r plus r minus 1, which is equal to 2r minus 1. So yeah, then the area is equal to 2r minus 1 squared. How do I get r though? Oh, okay. Maybe I can use a property of this. So wait, r minus 1/2. I erased all the goodness. No, I think I got it. Okay. Right. So this is a thing where, like, I have two unknowns, right? I don't know area, I don't know r. I need a second independent equation to link the two. I'm going to use this triangle to link it. So if this is r minus 1, I'm going to say r minus 1 squared plus half the side length, so plus 1/2 2r minus 1 has to be equal to r squared. Right? Here we go. Now I got it. Okay. R squared minus 2r plus 1 plus r minus 1/2 equals r squared. Wait, no. Wait. Yeah. R squared minus 2r plus 1 plus r minus 1/2 equals r squared. Okay, cool. So this goes away. This goes away. I get negative r plus 1/2 is equal to 0. Oh, r equals 1/2. Okay. So then the area... Wait, that means the area equal to 0.
Oh no.
No. Wait, pause. Yes, you are correct. Oh, my brain's done.
Oh no.
My brain's done. This is why I wanted to close the stream here, mathematician. Oh my god. Okay. Alright, fine. Alright. A quarter r squared. Actually, okay. I'm just gonna multiply it through. R minus 1/2 squared. Okay. So that's plus r squared minus r plus 1 is equal to r squared. Okay. Oh, is it a quadratic then? Oh, I guess it is. Sorry. This is plus a quarter. Okay, now I can cancel those. I get r squared minus 3r plus 5/4 is equal to 0. I don't know. What's the quadratic for this? I don't know anything off the top of my head that multiplies. The x. X squared minus 3r plus 5/4 equals 0. Just solve it for me, dog. Here, solve this. Cool. All right, so the values are x is a half or x is 5/2. Can't be a half because then it would be smaller.
Disqualified.
So r equals 5/2. Okay, fine. So then if I finally do this, area is equal to 5/2 times 2 minus 1 squared. Cancel, cancel. 5 minus 1 is 4. The answer is 16. I think that's correct, right? Yeah, we'll take 16. I think so. What happened to mathematician, dude? Mathematician, you're the one that were on my you were like on my back, dude, about this question. I went and I did it for you. Kind of a fun one though. I feel like I've done this before. I think I got lucky to find an easy way that you got so close to with your equation c squared equals 2r plus 1. Yeah. I got so close. Okay, whatever. We're just going to call it. Cool. All right, let's close the stream.
That's dope. Good job.
All right. Thank you, everyone, for coming to Action Education Office Hours. Appreciate all the discussions, questions. Thanks for tolerating students asking about the exam.
Oh no.
It's all good. We're gonna have a chess tournament tomorrow, so come on by, come play chess if you want. We're gonna give out prizes and stuff. And then also, I'm not teaching at UCLA next week.
That's dope.
So I will have more time for us to run fun shit in the server, and at least until I go to Burning Man, which is at the end of the month. So you guys get Dr. Gold back for a couple weeks, 2-3 weeks. Oh, nice. Okay, yeah, that would be a great one. C squared equals 2c, and then you're done. Yeah. Okay. Let's go raid someone. I'm tired. I'm gonna go say hi to him. Let's help Nerduino out. Yeah, we need to help Nerduino get over his 75 for partner push. Let's go say hi to him. Okay. All right. Enjoy the rest of your Thursday. We'll see you on Friday for chess. Otherwise, we'll see you next Monday. Peace.
No. Okay, is that better? No, this is a disaster. This is 7 different kinds of disasters all rolled up into one. I'm pretty sure it's NVIDIA Broadcast that's causing the trouble.